Hello. In this video, we're going to continue with logarithms and we're going to look at an interesting application. To review, if I ask you to solve 2 to the x equals 8, I think you could come up with that. A little guess and check. You could maybe make the bases the same. Let's do bases the same. That's a good method, right? 2 to the x equals 2 to the power of 3. Drop the base, x equals 3. Or 2 to the x equals 16. 16 is 2 to the 4. Same base, drop the base, x equals 4. Okay, but what about 2 to the x equals 10? Well, you can't really, 10 is 2 times 5, but it's not really like a power of 2. There's this extra 5 going on there. And you might be like, seems kind of tough. The answer is probably between 3 and 4, right? If 2 to the 3 is 8 and 2 to the 4 is 10, maybe 2 to the and 2 to the 4 is 16. Maybe 2 to the 3.5 is 10, right? And, just for fun, let's just try it. Let's try 2 to the power of 3.5. When I do that, I get 11.3. So not 10, I get 11.314. So let's try it. Let's try taking 2 and raising it to different powers. We're trying to get 10. So you could try 2 to the 3.4, maybe go a little lower. Oh, that's 10.5. 2 to the 3.3. Ooh, that's pretty close. 2 to the 3.3 is equal to 9.849. That's pretty close to 10. Maybe we could try 3.5, or we could just kind of, like we said, we could guess and check here. 3.4, 3.3 maybe. We can keep adjusting that power. Ooh, 2 to the 3.33 looks pretty good. That's approximately 10.056. If we go slightly lower, 2 to the 3.28. No, probably should stay with that 3. So let's go 328. Let's try that. 3 to the 328. Well, that's nice. 3 to the 327. 26. 2.5, 2.4. If you're following along with your calculator here, these numbers are getting pretty close. Oh, I like this one. 2 to the 3.322. Try that on your calculator. You should get 10.000498, which to 3 decimal places would round to 10. So I guess 3.322, that's pretty close. That's pretty close. But this method kind of sucks, right? Like, you're going to be here all day if you just have to guess and check to solve for x. Like, say, okay, so x equals 3.322 because I tried a bunch of numbers. If only there was a way. If only there was a way of saying, what power of 2 gives 10? What power of 2 gives 10? Because that's what this statement is saying. In English, this is saying, what power of 2 gives 10. I think we've seen that before. I think if we wrote log base 2 of 10, that would mean what power of 2 gives 10. With the Mr. Peters approved calculator, let's type it in. Log base 2 of 10 should give you 3.32192, which rounds to 3.322. Look at that. Same. But we got the answer by just typing it in. No guessing and checking. Now, if you don't have the Mr. Peters approved calculator and you want to follow along, you could type in log 10 divided by log 2. It's like a weird thing called change of base. You'll get the same answer, but please just get the Mr. Peters approved calculator already. It just really helps with these log questions. All right, so let's see how this would work on a larger question. We've got 3 times 4 to the x plus 5 equals 23. First thing we can do is we could subtract 5. So 3 times 4 to the x equals 18. We could divide by 3. So 4 to the x equals 6. But unfortunately, we're never going to get a same base. 4 we could do is 2 squared, but 6 isn't going to be a power of 2. So here, we can't use the common base technique. because, well, I mean, 4 is 2 squared, but 6, you're never going to get some kind of 2 business. You're never going to get 2 squared, 2 cubed. It just doesn't work. So you have to now resort to logarithms. Logarithms are the only way to solve a question like this. And the easiest thing to do is just convert it from exponential form to logarithm form. So logarithm form, the conversion, we're going to convert it, looks like this. The base is the base, so the 4 becomes the base 4. And then the 6 goes right there, and it equals x. Because 4 to the x equals 6 is like saying, hey, I need to know the power of 4 to get 6. And the log says, hey, log base 4 of 6 answers that question. Then we just hit up our calculator, and we round to 3 decimal places. So x equals 1.292. All right, go ahead and pause the video and give this one a try. All right, assuming you tried it, we should subtract 2 from both sides. Then we can't get a common base, so we hit up the logs. This will give log base 5 of 12 equals 3x minus 1. Now, we have to be a little careful here because when we're working with decimals, we don't want to round prematurely. So I'm actually going to leave this as just a log. I'm not going to evaluate to the end. So I'm going to add 1 to both sides. Obviously, the 1 can't be combined, so it's sort of like log base 5 of 12 is kind of like its own thing. You just leave it there. Plus 1 equals 3x. And then we can divide by 3. So my answer is x equals log base 5 of 12 plus 1 all divided by 3. Now that I'm at the end, I can go ahead and type all this in on my calculator. It just works a lot better if you leave it like this. If you try to get the evaluation partway through, then you have all these nasty decimals to carry through, and no one wants to do that. So you should get x equals 0.848. All right, here's another one. Again, pause the video and give it a try. Remember, your goal is to isolate for that 5 to the 2x minus 1, and then to convert to logs. All right, so first thing we do is we subtract that 2. So 4 times 5 to the 2x minus 1 equals 12. Divide by 4, divide by 4. So now I get 5 to the 2x minus 1 equals 3. Then I convert. So log base 5 of 3 equals 2x minus 1. Now I can add 1 to both sides. Remember, the 1, because it's not a log, you can't really like combine it at all. Divide by 2. And there's my final x. X is log base 5 of 3 plus 1. Maybe just put that plus even further over, plus 1 divided by 2, which as a decimal should give you 0.841. All right, here's a really fun one. We've got -5, and now there's this e thing going on. But pause the video and give it a try. All right, so again, let's just follow our steps. We're going to subtract 4 from both sides. -5 e to the 7x minus 2 equals -25. Divide by -5, divide by -5. E to the 7x minus 2 equals 5. Now we take logs. So we get log base e of 5 equals 7x minus 2. Move the 2 over. Log base e of 5 plus 2 equals 7x. Divide by 7, and x equals log base e of 5 plus 2 divided by 7. Now if we go ahead and type this on our calculator, we should get a decimal. All right, so I'm getting 0.516. Now, just as a little aside, if you wanted to type this in a little bit easier, because maybe you had a hard time finding that E button, I mean, it is a little tricky. The E, remember, is the red symbol beside the pi near the bottom of your calculator. So typing in log base E is a little tricky. Not impossible, but maybe you're like, oh, that was a lot of work trying to find that button. Is there a shortcut? The answer is yes. Remember, log base e of 5 is the same as ln of 5. If you've never seen this before, this is a good little tip. ln means log base e. And the reason why we have a special symbol for it on our calculator, ln is right next to log, is because log base e, it comes up. It's a useful tool. We saw e back in the exponential unit. Remember, e is approximately 2.71. It's a special math number. And it comes up here in logarithms as well. It comes up so often that calculator manufacturers gave it its own special little symbol. Just as a heads up, this is read ln, so you would read it like ln, like the letters. Or you might pronounce it as the natural log. The natural log. We call it natural because later on in math, e is sort of like a very natural number to be working with. The only thing I would say is please don't pronounce it lon. That just makes you sound a little funky. So call it ln, like L and then n, or call it natural log. All right, we should probably do another one here because it's good practice with those e's. So go ahead and find the exact value here by solving it, and then find the decimal as well. Okay, so we subtract 7 from both sides. Negative 10 e to the 5x equals negative 49. Divide both sides by negative 10. E to the 5x equals 4.9. Then we convert to logs. So we get log base e of 4.9 equals 5x. Finally, we divide by 5, and so we get x equals log base e of 4.9, 4.9 over 5, which we could also write as ln 4.9 over 5 if we were just wanting to be a little more efficient. And then if we type that in on our calculator, we're going to get our final decimal, which is 0.318. Now, if they said solve for x, you're welcome to get that final answer. But if you notice, everything up until here technically needed no calculator. Kind of interesting, right? It's just subtraction, division, converting to logarithms. And so this all could be in the no calculator section. I wouldn't be able to ask you to go to that last step without a calculator. But if you left it like this, this would be called the exact value. And either one is fine, either this one or this one over here. Both of these are called the exact value. And so this question could come up in the no calculator section. And what you do is you just solve it like normal and you just don't evaluate at the very end. But if it's in the calculator section, of course, then you go all the way and you get the decimals. All right, so here's another one. Go ahead and pause the video and give it a try. Okay, so let's add 2 to both sides. 3 times 3 to the 9x plus 9 equals negative 9. Divide by 3. So we're going to get 3 to the 9x plus 9 equals negative 3. Convert to log form, so log base 3 of negative 3 equals 9x plus 9. Minus that 9. Log base 3 of negative 3 minus 9 equals 9x. Divide by 9. So x equals log base 3 of negative 3 minus 9 divided by 9. And that would, of course, be our exact value. And then if we were to type it in on a calculator, so let's go ahead and type this in. Log base 3 of negative 3 minus 9 divided by 9 equals, oh, I'm getting a math error when I type this in. Apparently this is error. Well, you might have realized earlier at this step right here, we have a negative 3 inside that log. Is that allowed? Can we take the log of a negative number? Is that legit? No, it is not. This is undefined. And so right at this step, because we tried to convert to log form, but we got a negative number, right here, when we did this, we should have crossed off the rest of this. Boom, boom. We should have said no solution. The answer is no solution. You cannot take the log of a negative number. As soon as you try to, you just stop the problem and you say no solution. All right, so for this last one, I need you to find the exact value, and I don't want you to use a calculator at all at the end. So just find the exact value, see what you come up with. All right, so we'll start off by subtracting 4. It's going to give us 4 times, sorry, maybe I'll move that over here. 4 times 3 to the 3x minus 2 equals 17. Now I'm going to go ahead and divide by 4. So divide by 4, divide by 4. 3 to the 3x minus 2 equals 17 over 4. Okay, now I'm going to convert to log form. It's going to give me here log base 3, 17 over 4 equals 3 to the x minus, or 3x minus 2. Got to move that 2 over. So you get log 3, 17 over 4 plus 2 equals 3x. Got to divide out the 3. So x equals log base 3, 17 over 4 plus 2 divided by 3. And there's your exact value. That's the exact value. It's not nice. No one said the exact value would be like a simple or a easy to write down answer, but that would be the answer, and that's what you would go with. All right, so let's go ahead and take some notes here. This is solving equations using logarithms. Solving equations using logarithms. And the basic steps for this are use algebra to isolate the power. Right, the power term will be like the 2 to the x or something. That will be your power term. And then convert to log form. So that's like if you have 2 to the x equals 10, you convert that to log base 2 of 10 equals x. If you're wondering how to convert it, the base becomes the base. That's the easiest way to track it. Then the rest should work out. And then from here, you solve for x, and you can leave it in exact form if you want, or if the question asks for it. So let's go ahead and try an example here. Let's do 2 to the 4x minus 3 plus root 7 equals 15. So go ahead and pause the video and give it a try. All right, so you'll know you did it right if the exact value you have is 1.657. So if you got that as your calculator value, good job. If you had a little trouble with the algebra steps, I'll show you here real quick. So you move that root 7 over to the other side. It's 15 minus root 7. You convert to log, so you get log base 2 of 15 minus root 7. And then I'll do the next steps together. We move the 3 over and divide by 4. So x equals log base 2, 15 minus root 7, plus 3, all divided by 4. Also, if you're having trouble typing this in, on the Mr. Peters Approved Calculator, there's a little button for fractions and a little button for logs with a different base. So you should be able to type it in actually on your calculator and make it look exactly like it looks on the paper. But if you're struggling with a different calculator, sometimes you have to add like extra brackets here, different things like that. So best of luck if you're using a different calculator. Now, this is in Unit 9, worksheet number 5. So you can try that for extra practice, and then write down any things to remember. Of course, in this lesson, it's probably really important to remember that log of a negative number is undefined. So if you're ever working on any kind of log question and you convert to log form and suddenly you have a negative inside your log, you know it's time to call it a day and say that there will be no solution. All right, hopefully you enjoyed this video, and as always, thanks for watching.